Alright, I got this around Christmas time. It's a battery. It's a sealed lead acid battery. It's a 6-volt battery, 1.3 amp hours. And it says some charge capacity is C divided by 5. So if you want to charge these batteries, you charge them at a constant voltage with a limit on the current. And the limit on the current is 1/5 of the 1.3 amps. And it says here for cyclic use, you can draw 0.39 amps, so 0.4 amps. I think the rover's probably less than that. I don't know, we'll see. I actually haven't measured the current draw of the rover, but I think it'll do the job. It comes with this little protective caps here on the battery, and then I'll use some of these press-on connectors on some wires. And the rover has a 5-volt regulator on it for the 5-volt logic, and then it uses raw voltage for the H bridges and the motor, so it'll take the raw battery voltage. And then hopefully there's enough headroom in the regulator that the battery will be able to overcome the burden of the 3-terminal regulators. It says here voltage regulation standby use 6.8 volts. So typically, even though it's a 6-volt battery, it's running higher than that, so it should be okay. If it runs a little low, I think the Arduinos will still run just fine on low voltage, so no worries there. So let's see if we can hook this thing up and figure out where to mount the battery. I'm not exactly sure where to mount it. I don't want to put it on the PC board because I want to have room there. Maybe there's some place to put it underneath the rover. I'll figure that out. Alright, so I think I'll make a strap, some type of, put it on this way. So it'll be a strap of aluminum with a couple screws that go down. I think that'll hold it. So maybe an inch wide strap. So we'll make that out of some aluminum, and get going. So what we need is a 1-inch strip, so let's cut that out right now. Okay, I've got this shear. It's a cute little shear. I got it from a friend whose business was going offshore. They were shutting down the operation, and basically everything in the lab was going in the dumpster, so I saved a few things from the dumpster, and this was one of them. It's a Key Pro shear. It's made out of aluminum. It's interesting, and it's about a 12-inch shear. Let's see. So I have some plate aluminum here, some T6. Let's see. So we will measure off an inch and shear it. Let me find something to measure with. All right, so I'll line this up onto the cutter. Use the fence here. How are we doing? That's about right. And there we go. Oops. 1-inch strap, and we'll put some folds in that, and be ready to go. Let's see. Our line there, and hit it with a hammer. go, 90 degrees. And put a couple of bends in it and be ready to go. I don't have a brake, otherwise I'd do it nicer. Alright, so I've got some bends, fits the battery, and so just need to cut it off there, and then we'll have a way to cinch down the battery. Go over here. About right. A little crooked, but that's okay. Probably should have done a little better. But yeah, I think that'll work. That'll work real good. Alright, so we have our strap here, and I think I'll find maybe a place underneath, up underneath here somewhere to put that strap and get it battery powered. Alright, there we go. So I got the couple screws down, tapped into this plastic, and hold the battery down, and it all fits underneath, and we'll put some connectors on it, and should be good to go. Okay, I got the negative here, positive here, it's all wired in, and if we flip the switch, it starts to run, so let's stick it on the ground, see what happens. Alright, let's turn it on. There it goes. That's the same little program that I had that just kind of goes left and right and forward and backwards. My heater is cycling on and off. I'll turn that. Anyway, seems like it's actually doing something. So it's doesn't need to have a tether anymore. It can operate on its own. So that's pretty cool.